Hey programmers, welcome to the video. So we will be solving day 6, 6th of October problem, swim in rising water today. So let's directly jump into this. Okay, this is a hard problem by the way. Let's look at it. You are given an n cross n integer matrix. So let's first understand this step by step and then we can think of their intuition and approach. So we have given an n cross n matrix. Basically it's a square matrix first of all. Okay, and grid, which is grid ij equal to represent the point I comma j. Okay, it start raining. Okay, it's related to rain again, and all the problems in this October Leetcode challenge are related to some water, raining, trapping rainwater, something like that. So and water gradually rises over time. At time t means t equal to, let's say, 0, t equal to 1, 2, 3, something like that. The water levels t means level is t. Okay, water will fill up to the t level. Okay, meaning any cell with elevation less than equal to t is submerged into the end or reachable. Okay, so we are a swimmer in this question. As per this question, we are swimmer, so we can swim to that cell which is submerged, which is like underwater at time t. And what all cells can be underwater whose height is less than t. Okay, so you can swim from a square to another in four directional adjacent square. So we can go like up, we can go left, we can go down, we can go right. So these four adjacent sides we can move, we can swim all the four directions. We can't go diagonals, we can only move in the square, in the four direction only. Okay, if and only if there is a condition when we can move, if the elevation of the both squares individually are at most t. So let's say elevation of this is 10, elevation of it's 8, and t is equal to 10. So both elevation of both of them it's at most t. Okay, so 10, so we can swim through it. If it is 11, so at most 11, and t equal to 10, it's greater than, so we can't swim. So basically it should be submerged. You can swim indefinite distance in 0 time. Okay, let me remove simple terms first. So there is no time window that we can swim x to y and it will take us one time. We can, like, in 0 time instantaneously we can go from x to y, like a comma b position to c comma d position we can go in 0 time, near 0 time you can say, instant. Okay, of course you must stay within the boundaries of the grid during your swim. Obviously we have to, like, we can't go outside this grid and come here, something like that. Okay, so return the minimum time until you can reach the bottom right square n minus 1 n minus 1. So, and if you start at the top left square 0 0, so we will start from here and we have to reach here. That's the goal, okay. So for the first example, if you see that they are given that we have a 0 2 1 3. Okay, let's understand something like that, 0 1 2 3, and we haven't reached somewhere. We will start from here, we will start from this cell, 0 0 cell. Okay, so how much time should be passed so we can reach this cell? We can reach this cell at 0 time. At t equal to 0, we can reach this cell because it's submerged. Okay, others are not submerged, so we can't go there. So it's like unreachable to us. Not reachable. Then at t equal to 1, t will increase. At t equal to 1, we can go to this cell as well. So we can go from up to down, and this cell is available for us to swim. So we can go to these two cells now. So this is 0, this is 1, still both, these both are unreachable. Then we will increase the time t equal to 2. If at t equal to 2, this cell will also become submerged. My bad. So we can reach here as well, right? So let me remove it. My bad. 2. So at time 2 we can reach to these three cells. These three cells we can reach. Okay, but we still can't reach here. So at t equal to 3, we can reach here. We can actually go there and reach here, right? So let me what? At time 3 we can reach here. Okay, so in the grid answer is 3. At time 0 you are at the location 0 0. you can go anywhere else. I can't go anywhere else because at t equal to 0, only this cell is submerged, other cells are above, so we can't go and swim there. Okay, neighbors have a higher elevation than t equal to 0, you can reach 0.11 until time 3. When the depth of water is 3, we can swim anywhere inside the grid. Okay, so when depth t equal to 3 becomes, so all of the grid will be submerged and we can reach anywhere. Okay, so let's better understand in this example number 2. I think there is a better example given. Yeah, it looks a bigger grid, so we can understand this probably with this example more. So this grid is given at t equal to 0, we are here. T equal to 0, we are here. Okay, and we have to reach here. We have to reach n minus 1 comma n minus 1. Okay, so what's the minimum time? What is the minimum time to reach here? At least 6. At least 6, because if we are reaching here in t equal to 6, then only we can swim to this. If t equal to 5, then we can't go there, right? So at least we have to spend this 6 minutes of time, so this cell can be submerged and we can move to this cell. Okay, so from this observation we can go like at least 6 minutes I need to go there. Okay, so if I want to go there from this 0, 0 location, how can I go there? I can go left, I can go up, I can go right, left, up, down. I can go in 4 directions, and I should move to this n minus 1. This is my goal. Okay, and we have to find a path in which the time taken is t should be less than, like t is minimized. Minimum time we have to find that at this t point we can reach this n comma n without any hassle. So for this answer we have a 16 is answer. So let's look at how this 16 is coming here. So when t equal to 16, which is our answer, we are backtracking it. When t equal to 16, we can swim through all these cells which is marked as colorful. Okay, all these cells we can swim through. This is a 16 in this path which were blocker if there is t equal to 15. Okay, let's say we will go with t equal to 15 only first. Okay, we can go t equal to 15. Okay, so at t equal to 15, what all cells are reachable? This cell, we can go there, we can't go there, we can go there, but there is no way. Like if we have swim through this cell required 21, this cell required 16, so we have covered these many cells and we can't go here as well, because to go at 15 we have to come from somewhere, right? We have to come from up, we have to come from right, left and down. From somewhere we have to go, somewhere we have to reach the 15. Okay, so can we reach from here? No, it's bigger. Can we reach from above? No, it's bigger. Can we reach from bottom? No, it's bigger. So from all 3 directions we can't reach, so only possible direction is 14. So can we reach 14? Question is, can we reach 14? From above it's bigger, so we can't reach, it's not submerged yet. Okay, can we reach 13? No. Yes, so it can be reachable from 13 because 13 should be submerged by them. And can we reach from 18? No. So let's look at for 13 now. So if the dependency goes to 13, okay, at 13, can we reach 13 somewhere, somehow? How can I reach 13? Can I reach from up? No. From down? No. From left? So there's the dependency only. So can we reach 13 from 12? Yeah, we can reach. So 12 is submerged. So if 12 is submerged and I can reach 13 from 12, so if we somehow reach 12, then we can go to 13, then we can go to 14, then we can go to 15 as well. Okay, that's the dependency we are traversing. And in this manner, if we traverse back, so we can reach 12 by from 11, we can reach 11 from 10, from 9 to 8, 7, 6, something like that. So somehow we have to reach 6 to make it possible. So we can submerge all these cells. These all cells are submerged, but we can't reach these cells because there is no way. There is no other path, because we are starting from here. We are stuck with this 5 and this 6, these cells only. We can't go anywhere else. This is a blocker, we can't go anywhere. These cells are submerged, all cells are submerged, but we can't reach here. There is no way. Okay, so at t equal to 16, what happens? This cell becomes submerged. If this cell becomes submerged, we can go through this. So we have to find that pivot point, like what's the time at which we can move from 0 comma 0 to n minus 1 freely, and this t should be the minimum pivot point. Okay. Okay. So what do you think? Okay. Can we do something like that? If we have the minimum value of this grid like 0, and if we go to like all the way to 24, which is like maximum value of this grid. Okay. Okay. And if I do binary search, if I do something like binary search, so I will do like at mid we have t equal to 12. Okay. So at t equal to 24, all the complete this grid will be submerged. At t equal to 0, this full grid will be open, only this one cell is submerged. Okay. So at t equal to 0, we are sure that we are not able to pass the bridge. At 24, we know that that's the maximum t we can go, like that's the maximum range of our answer. Okay. At t equal to 24, we have submerged all the arrays, so we can freely swim from 0 0 to n minus 1 Okay. So answer lies between them. Okay. Answer lies between 0 0 and 24. Answer lies between them. The maximum of this array and minimum of this array. Answer lies between them. Okay. And if you know that if this is sorted, the maximum and minimum, okay, treat it like a sorted array. And if I find the middle value, okay, so let me make a number line here to make it more clear. Okay. So let's understand, this is a minimum value, this is a maximum value. So this is a max time, this is a timeline. Okay, this is called timeline. Okay. Timeline. And this is min time to reach obviously 0 0 minimum value. Okay, which will be like grid of 0 0. Obviously we have to reach grid of 0 0 at least. So grid of 0 0 will become that minimum, and maximum of the maximum time will become the max of all cells. Okay. And if I find that at minimum time obviously we can't reach somewhere, and at max we can reach anywhere. Okay. So answer lies between them. Answer lies between somewhere between them. So let's take example. This is the answer. For example, this is the answer. Okay. Now traverse. This is the answer. So from these points, this t we can't reach, and at this timeline we can reach. Okay. At this timeline, if my t is smaller than answer, then I can't reach n minus 1 comma n minus 1, because this is the minimum pivotal point. That's why it's answer. And if my time is greater than answer, then obviously I can reach. If I can reach on answer, then obviously I can reach more time than answer. Okay. So from this, let's backtrack. Okay. Let me remove some strings. Yeah. So the first algorithm which comes to mind, which is like, can we divide it in half? We can divide this in half, and we will solve for that. If this is the answer, if this is the at this point, if we can reach n minus 1 comma n minus 1, obviously then we find the answer. Answer should be like not bigger than this, answer should be less than this, somewhere in this line. So from minimum time to this midpoint, we have answer somewhere lies between them. Okay. Then we divide it half equally again. We go here. Okay. And we find that n minus 1 is unreachable. We can't reach. So obviously we know that if we can't reach at this time, obviously if there is less time we can't obviously reach. So answer lies between them. Okay. Then we will cut it half again. Okay. So this algorithm is called binary search, right? You already probably know this. So we will do binary search, and like time complexity of binary search is something log of the timeline. Timeline max is like max of array 1. Okay. So there is given constraint that grid of I comma j can be maximum of n square and minimum of 0. So it will be log of n square. Okay. Which is log of n only. Okay. So in the binary search we can find the pivotal point at log n time. Okay. At each point At each point, what's the time? What's the time to find out? Find out, can we reach n minus 1 comma n minus 1? Okay, we have to reach n minus 1, n minus 1. So at this time we have to find, can we reach n minus 1, n minus 1? That's the main problem to solve now. Okay, so let's say, let me clear this drawing. Let's say this, let's run on this example only. So we have a minimum time as 0, we have a maximum time as 24, we will find mid time as 12. Okay, so at time 12, can we reach this n minus 1, n minus 1? That's the question we have to solve here. Okay, so at t equal to 12, I will be reaching here, obviously, right? I will mark this, I can reach here. Okay, then I will move from this to above, there is no cell, either no cell, down, I can't reach because it's bigger. I can reach there, this is submerged, I can reach here. Then can I reach here? No. Can I reach here? Yes. So this is submerged. Can I reach down? No. Can I reach here? Yes. This is submerged. Can I reach here? No. Can I reach here? Yes. So this is submerged. From 4, can I reach down? Yes. Bilkul. Can I, from 5, can I reach 16? No. Can I reach 21? No. Can I reach anywhere else? No. So these guys are only reachable. This is the only path. These 5, 6 guys are only reachable at t equal to 12. Okay, that means we haven't seen this n minus 1 comma n minus 1 in our part reversal. We can't reach n minus 1 and n minus 1. That's why our answer lies between 12 and 24. We need more time. Okay, then our search space will be shrink to 12 to 24. Okay, so midpoint will come at 18. Okay, so at 18, t equal to 18, at t equal to 18, let's travel back. Let's traverse, can we reach? Okay, so for t equal to 18, if we start from 0, can we reach? Yes. Can we reach here? Yes. 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 Okay, we can reach here. Can we reach here? 24? No. 23? No. 22? No. 21? No. Can we reach at 5? Yes. So all these 5 guys are already reachable, obviously, in previous iteration as well. So we will be able to reach here easily. Okay, now is 16 reachable? Is this 16 reachable? Yes, because t is 18. So now from 5 we can go to 16. We mark it as visited, like it's reachable. We mark it as reachable. It's a reachable cell. Can we reach 20? No. Can we reach 15? Yes. Can we reach 21? No. Can we reach 19? Can we reach 19? No, because it's bigger than 18. We can reach only 14 here. From 14, can we reach up? No. 13? Yes. 18? Yes, we can reach 18. At t equal to 18, this will be submerged. And this is the guys. Okay, now from 13 we can go to 12. From 13 we can go to 17. These are reachable. This 11, 10, 9, 8, 7, 6, all these guys are reachable. From this also, these guys are reachable. So these guys are reachable. N minus 1 comma n minus 1, I have reached at equal to 18. Okay, so I surely know answer lies between this 12 and this 18, including maybe this 18 is a pivotal point, including 12, including 18, I know answer lies between both of them. Okay, so midpoint will be come out to be like 15, equal to 15. Midpoint will come again in the third iteration. What I will do, let me remove some drawing. Okay, I will again check, can I reach n minus 1 comma n minus 1? Can I reach n minus 1 comma n minus 1? So if you notice clearly that we can reach only these 5 guys, only these 5 guys we can reach. We can't reach 16 here, right? Because its time is less than like this cell is not submerged, so all these cells are submerged, but we can't reach. There is no path to go. There is no path to go. Okay, so obviously we can't go. Now let's move to more. So we need more time, obviously, right? So we shrink our timeline to 15 to 18. 15 to 18. Okay, so midpoint will come out to be 16. Let's for this example, let's take 17 first. Okay, let's take 17. Okay, at t equal to 17, as we already know, we can reach all these cells. So we will be able to reach n minus 1 comma n minus 1. Okay, 17 is the answer. So we will shrink this timeline to 15 comma 17 now, and midpoint come out to be 16. Okay, so we will check for 16. At 16 we can reach, yes we can reach. So our timeline will shrink to 15 comma 16, and we will check for, we will always check for smaller one first. Okay, so can we reach 15? From 15 we are blocked till here, we can't reach. Okay, so obviously our mid will be that 16. Okay, so 16 so this point will be increased, so 16 comma 16, and our answer is 16 only. Okay, this is how we can find the pivotal point using binary search. So the only challenge is now coming is how to find, can we reach from 0 0 to n minus 1 n minus 1 at given time t. So t is given from binary search, we have given, we need to find that is reachable. Okay, is n minus 1 n minus 1 reachable, we have to find this. If it is reachable, then this t is the answer. Like t from t and less than this, so t answer is less than equal to t, simple, if t is reachable. Okay, so we have to implement something like this, is reachable, in some better time complexity. So n is 50, can we go n square? Yes. Can we go n cube also? Okay, so 50 cross 50 is 20, this is like 10 to the power 2 by 2, and cube is 10 to the power 6 by 8. Yeah, so yes, we can go till n cube, we have a full luxury, like we can go up to n cube, and we already know that binary search will take log of n square, which is log of n, the time complexity will come out to be n cube log n square, or which is n cube log n. We can go up to that, but optimize, if we can optimize it better, it's good. Okay, so let's think about it. How can we go from this location, cell grid 0 0 to end of this? How can we go? Okay, okay. In a most optimal time, okay, we have to traverse, like first let me mark it as visited, we can go to 0, obviously I mark it as visited, and from this I can push that 1 can be visited and 24 cannot be visited, so leave the 24, I can reach 1. Okay, I will store somewhere that 0 is now visited, 0 is like gone, we have reached to 1. Okay, so is now from 1 we can reach to 2, and I will mark that 1 is gone now, 1 is gone now for us, we have reached till 2, from 2 we have reached till 3, from 3 we have reached till 4, till 5, something like that. Okay, let's say example t equal to 17. Okay, so t equal to 5, or for example, let's, for the sake of it, let's take t is like very big, t is like 20. Okay, to understand this better, like can we traverse, how we will traverse in better time. So from 5 we can reach to 16, yes, from 5 we can't go to 21 because 21 is less than. From 16 we can go to 20 as well as 15, we can go up 20 as well as 15. Okay, and this is reachable, this is reachable. From 15 we can go to 14, 19 is reachable, then from 20 we can go to 6, 7, and in the path, if somehow we reach n minus 1 comma n minus 1, we don't have to care much, we can, if we can reach n minus 1 comma n minus 1, then there's the solution. But basically is reachable is true. Okay, we can go 16, 26, we don't need to go traverse all the path and go here, this is the minimum time taken, but at t equal to 20 we have the luxury, we can go directly down. Okay, so we need something to traverse, like we traverse this, then we will take out this, something like if I have gone through this path, so in the path I have obviously marked, from this I have started, I will take it out, I will push that, push the new nodes which is adjacent to that into the our system, and then we will like take this out and push its adjacents. So something like queue kind of data structure, we can push the indices, I comma j here, and then if we pop out, we will add adjacent of that. So we have 4 adjacent cells, we can push adjacent of that in the queue if it is reachable. If it is not reachable, then it's okay. So if somehow in the iteration, if we reach this n minus 1 and n minus 1, that well and good. If we can't reach, then there is a problem. So we will return as false. Okay. So like I hope algorithm in this explanation is clear now. So we can like quickly jump into the code. Okay. Let me remove the drawings. So first of all, let's find the length of grid, and if length is 0, then we don't have to do anything, but length is greater than equal to 1, they have seen, and is greater than equal to 1. Okay, they have. Okay, so let's find int min time as grid of 0, 0, obviously. If grid of, we can't go grid of 0, 0, then we can't start. So that's the minimum. Obviously we have to go to grid 0, 0 to start our calculation. Okay, and max time will be the maximum of max of all the array elements. Okay, so int max time, so all the grid elements is greater than equal to 0. So let's define as -1, and we will iterate over the loop, iterate over this grid and find the maximum value. What's the max? Okay, let me quickly do that. Okay, max time, it will take equal to max time comma grid of ij. That's it. So now we have a min time and we have a max time. Okay, so can min time be bigger of max time? No, because max time is the maximum of all the elements. Can min time be equal to max time? Yes. So if min time equal max time, means that's the condition, like that's the maximum element. 0, 0 is the maximum element, so we don't have to calculate anything. If we can reach 0, 0 at the time, all the cells are submerged, because that's the maximum value, and we can reach easily from 0, 0 to n minus 1 and n minus 1. So we will return easily min time or max time, anyways, both of the same. Okay, this is the edge, one of the edge case, like if grid of 0, 0 is too big. Okay, now we can go and do some binary search here, and we will create a function is reachable. So we will create a boolean function called is reachable. That's it. Okay, so let me quickly create it. First, boolean is reachable. So in that is reachable function, what we will give him? We will give him the grid, the complete grid. That's our grid. And can we reach from 0, starting from 0, 0 till n minus 1 and n minus 1 at the given time. Okay, so we will pass the time as well. Okay, so as we discussed, we will implement a queue data structure here. Okay, so let me take the size first here. Size, it's always a better practice to make it private, so let's make it private function. Yeah, great, because it's a abstraction here, right? We are not showing this to our main function. Main function will be like clean, it will be calling to these private functions, and this will be solving our problem. So okay, so we have a grid size, we have started at 0, 0. So let's go to, let's make a queue of I comma j. So it will be like pair of I comma int, my bad. This is our queue, and we will push 0, 0 in the queue. So time will be obviously greater than equal to 0, grid of 0, 0, and we can find that it's easier. We can easily push 0, 0. Obviously we can reach at the minimum time, in grid 0 0, and we have started our all the times is greater than equal to minimum time, so we can always reach 0 0. Okay, we can assume that easily. Okay, so we will while if queue is not empty, we will traverse to the queue, we will pop this top element and let's mark it temp element q dot front q dot pop. Okay, so from front we find that what's the current x and y position. So x position is equal to temp dot first and y position equal to temp dot second. Okay, that's great. So we have find, now we have to loop through these directions as well, so all 4 directions. So let me define our vector of directions. Direction of rows and direction of columns. Direction of columns. So how I define it? I define it like if row keeps, like row is the same, then we can increase the and decrease the column, increase and decrease the column. If if we keep the column as same, no change in column, we can increase or decrease the row. That's how we form a vector, and we will traverse it. For I plus plus, we will traverse this, and we will find the new coordinate. Okay, so int new row will be like old row plus direction of row of I. Okay, similarly new column will be y plus direction of column of I. Okay, and we obviously have to check if this new row and new column is valid. So if is valid, new row comma new column comma n, and then what need to find, let's make this is valid function first. So we have a boolean function is valid, int x coordinate, int y coordinate, and int number of rows or like number and value. Yes. So if x is greater than equal 0 and then x less than n, and then y greater than equal 0 and then y less than n, so we can return true here, and otherwise we can see return false, that it's out of bound. Okay, it's not valid, it's not a valid cell. Okay, so if a valid cell, then we will do something, otherwise so we don't have to do anything. If it is a valid cell, what we will do, if we are going somewhere, it's a valid cell, and that's the fundamental. What is the fundamental question? Fundamental question is that can we reach there or not? Simple. Can we reach there or not? Yes, if it is less than the time, then we can reach there. If not, then we can't, obviously, right? So if grid of new row and new column is less than equal to our time, okay, then so we can reach, otherwise we can't reach. If we can't reach, else what to do? Nothing to do. Okay, so can we merge this if condition with the above if condition? Obviously yes. Then let's merge it like this. We don't need this. Okay, so we can reach this new row comma new column, so we will push this in the queue. Push new row comma new column. Okay, something like that. Okay, and we have to check also, right, that here if this new row is n minus 1 and then this new column also n minus 1, then obviously we have reached till end. If we have reached till end, we will return true. We don't need to go further somewhere, we will simply return true. It's a reachable cell, If until the QA is empty we can't reach, then we will return false, that we can't reach to that cell. Okay, Simple, as simple as that. Okay. Now I think this is clear to you. There is one caveat, wait caveat. Okay, so I will explain like something like that. Okay, so if we start from zero, we will push one, in some direction. In 4 direction, these 3 are blocked. Let's say we have push one. When we are searching for one, we can't go up, we can't go down, we push 2, and we are again pushing 0. So this 0 will be keep looping in that, right? We don't have to iterate it over again, right? So we have to mark this is visited, like we have seen this before, we don't have to go there again, right? So to make it, we will create some visited array, like boolean visited matrix, which is easy to make. Let's फटाफट में बना देते हैं. So we will make vector of boolean, let's mark visited. If we have visited that cell, it will be n size vector of boolean, and again n size vector with false as a default values. Okay, now we have marked this. Let's mark visited of 00s true, since this is the starting point. And if we are pushing something, if we have pushed something, just after push we will mark it as visited, that we have visited that cell. Okay, so just after push into the queue, we will mark that we have visited that new row and new column. We have visited, okay, equal to, and we have visited, then we will not visit it again. So we will, if not visited, we will add another condition here. If not visited, let's make this condition before our calculation, and then not visited of new row and new column. So wherever we are going, new column, wherever we are going, if it is not visited, then we will calculate this and push into the queue and mark it as visited. Okay, I hope this is reachable function is clear. I hope it will run. Okay, so this second part is done. Boolean reachable, this is done. Now the part is remaining is binary search. Okay, so we have a min time, we have max time. Okay, both are calculated now. So we have to do binary search between min time and max time. So let's keep it here, between min time and max time. Okay, so what we will do in binary search, we will make the midpoint between mid and max time, and we will keep this running, is reachable function running. If it is valid, then we will move the min time and we can move the max time, something like that. Okay, so we will go while min time is less than equal to max time, then we will run this loop. If it is exactly equal, then obviously at the first we will return min time, and if it is less than, then we will run the while loop at the starting. After that, min time and max time will be keep changing, so doesn't matter. So we will check midpoint is min time plus max time minus min time by 2. Okay, I think yes. Max time minus min time by 2, and we will add min time. Okay, so that's the, yeah, correct. So this is like minimum mid, so it's called low mid, and there is one more mid. So if there is 4 elements, let me explain something like this. If minimum is 1, maximum is 4. Okay, so we have between 2 and we have 3. So what mid to be considered? Like 2 is considered, 3 is considered, which to be considered? So there is 2 mids here. If I do 1 plus 4 minus 1 by 2, then it will be a low mid. Low mid means it will be like 3 by 2 is 1, and plus 1, so it will be 2. And if I do 1 plus 4 minus 1 plus 1 divided by 2, then this will be a high mid. This is called high mid. This is a low mid. Okay, so this is a low mid and this is high mid. So for this sake of problem, we will find low mid. If at the low mid we have find the solution, we can reduce our high to this. Okay, if we not find the solution, we will increase this to this plus 1. Okay, something like that. So let me remove the drawing. We will go with the low mid first. Okay, so I have explained how we can find the maximum, like low mid and high mid, both of them. Okay, so add midpoint. Let's check if it is reachable. If it is reachable, okay. If is reachable. So if this function, let me call this function will be called now, it's useful now, and we will find the mid. So let's call it mid time or mid for simplicity. Okay, if it is reachable, then what to do, and if it is not reachable, then what to do. That's a simple question. Okay, so if it is reachable, then our mid time will become like we have a good enough time. So at this time it's reachable. After this, each time it's reachable, so we can reduce our max time to this. Okay, we'll make max time equal to mid. Simple, very simple. Okay, if it is not reachable, it's else condition. If it is not reachable, then at midpoint we can't reach, we have to go for mid plus 1, obviously, right? So our min time should be mid plus 1, correct? Mid plus 1 it should be, because we are not able to reach let's say 0 to 30, between is 15 I can't reach, so I have to go mid plus 1, like 16. At 16 I will put my min time and max time will be 30, then it will be lower, it will come here. Okay, and at the end we will return this min time. This will only remain, like min time or max time both will be the same. If both of them is same, then mid will be like minus 0, mid same, and at min time we can reach, yes we can reach. Okay, so max time will become mid minus 1. Okay, we have to do something like that. Mid minus 1, we have to decrease this as well, otherwise to this while loop will never come out in this. At equal it will run, right? So either we can remove this equality, either we have to move high pointer to, like, the maximum time to mid minus 1. Okay, so if I move to mid minus 1, let's say mid is reachable, mid minus 1 is not reachable, we have left with the some array which is like not reachable at all. So all will for go in else condition, mid plus 1, something like that. And at the end we have a 3 elements, let's say, then 2 elements, then we have a lower. Always we will find in the lower, we will look at it. Okay, then so obviously we will go from lower mid. Okay, so let me show this. So let's say we have two things. Okay, let's say t equal to 7 and t equal to 8. T equal to 9 was omitted because I have did mid minus 1 here. So this is the answer. These both are not reachable, and this is the lower mid. Okay, and it is not reachable, so I will make min time as higher mid. It will be this one, it is the same, so mid will be that same. It's not reachable 8, yes, not reachable, so min time will be plus 1. Here we will come here and we will exit from this loop. Okay, we can exit. Okay, so our answer will be like min time only. After exiting, it will be min time. So let's run this and let's debug if there is an issue. There is an issue. It's calling in here pair of integer comma integer. Okay, both the test cases are passed. Let's submit this. let's summarize this. Yeah, it's accepted now. So I hope you found it well. What are the topics given? Array, binary search. Yeah, we have solved it from binary search. DFS, BFS, union find, heap, priority queue. Okay, priority queue. We have solved it from the queue perspective with visited. Can we solve it from priority queue as well? Like we can think of a priority queue as well. Oh, okay. If I give priority to the smaller element first, that it will pop out first, we can reach faster here. Either we can reach faster here, okay, something like that. Okay, so it's a homework for you guys that you solve it for using the priority queue. I have solved it using the binary search example. So hope you found this problem interesting, and I hope you understood the problem approach and intention behind it, how we find the time and how we find this, how we played out well these constraints so we can use the binary sets in our favor. Okay, so bye, let's meet tomorrow. Happy coding.